All right, let's do a little intro into volumes by slicing. Full disclosure, your teacher is not very good with this stuff. I'm going to tell you right off the bat. 6.3 and 6.4, I struggle with this a little bit. So I'm going to do my best to explain it. I'm going to use a lot of examples just straight from your book so you can see the pictures because you can tell that your teacher cannot draw. And there's a lot of drawing in this. We're going to be dealing with volumes. So I'm going to use a lot of examples from your book. Reason being is I don't draw well, and I'm not good with the visuals. So hopefully I can do a good enough job to explain this to you. If not, maybe you use another resource that has better pictures or something. But I'm going to do my best. And I think if I do my best and you do your best, I think we'll get this done. So, all right, let's jump into it. So this one's just for the idea. We're not going to do a problem. We're just going to think about what's happening here. So we're talking about a volume, and here's just some crazy formula. But this should seem pretty familiar to you, huh? Haven't we seen something like this? Haven't we seen something like this that looks like the sum from k equals 1 up to n of f of x of k star delta x? Isn't that like equal to something, especially if we take the limit as n tends towards infinity? Isn't this just the integral of the function? And shut up, kitty. Sorry, kitty yelling at me. Actually, she's yelling at my dog. All right, so same sort of game we're going to have here, except our function is going to be an area function. So we're just going to have to figure out the area of something. But we got our area formulas down. You know how to find the area of a square, don't you? You know the area of a circle. You got those down, don't you? All right, cool. Let's move forward. So here's just like a random old picture of some shape from some point A to some point B. I don't know why I said point, some value of x from A to B. Now, if we cut it, all right, you take a cross section, there will be some sort of area that looks like it's shaped like a parabola. All right, so maybe there's some formula for a parabola that we could get. But there's no thickness to this, and we want to get the volume. Volume has 3 dimensions. Area has 2 dimensions. All right, so that's the area, but we're trying to figure out the volume. So what we'll do, just like we had done before when what was it, when we were trying to find out like the area under the curve, we would take rectangles. All right, remember this? Rectangles, and we'd add them up, and then each one of these had a thickness of delta x. That's the same game. So we're going to take a bunch of these areas, we're going to multiply it by our delta x, the thickness of the slice. But as you can probably tell, we're going to take the limit of them. So we only have k slices down here, or n slices. I'm sorry, I said the wrong one. We have n slices, and for that example, I don't know, maybe there's 10 of them in there. So we wouldn't get a perfect volume, but if we take the limit as n tends towards infinity, bang, we're going to have it. So let's see more pictures. So we start up here with this isn't the best of examples, right? It's close, but as long as we increase the number of slices, it's going to get closer and closer and closer until n tends towards infinity, and then we're going to actually have the volume. Now, I hope you're holding on with this. This stuff is not the simplest. So for a general slicing rule, it's just we're going to find the volume to be from A to B of some area function. And that's going to be our job, is to find out what the area function is, dx. And it seems simple enough, but dude, it's very complicated because you have to come up with your own formula when it comes to just shapes. Now, the beginning of this is just going to be shapes. Soon we're going to have, all right, here's a function. Let's rotate it about an axis. This is just shapes. And again, full disclosure, this is where I struggle probably the most. I don't see this stuff well. We all have our strengths and our weaknesses, and this is most certainly one of my weaknesses. And hopefully I get better through the semester along with you. So, yeah. We'll jump into some problems next. We'll do 2 of them. We'll do a parabolic cube. Do you know what a parabolic cube is? Either do I. But we'll figure it out. And then we'll do what's called a parabolic hemisphere. This is just example 1 and example 2 from your text. So, all right, I will see you in the next video.